Yeah, hi everyone, Mr. Market here again. In today's video I'm going to show you how to calculate standard deviation using the graphics calculator. There is a formula used to calculate standard deviation, but for the sake of this video I'm just going to show you how to get that through the graphics calculator. Again, I'm using the FX CG 50 model, but most of them are pretty similar in terms of their functionality. Now, for the sake of this video, I've already put the data into that list in the stats function. So if you head into the stats function on the graphics calculator, you'll come up with your list here. I've already put sample A into list 1 and sample B into list 2 there. So I'm going to go ahead and answer these questions, starting with the range and interquartile range, and then getting to the standard deviation question in a minute. So let's start with question A for sample A. Color code that purple. Again, when you've put in all the values there, okay, whoops. Graphics calculator. Once you put in all those values there, which I have, just make sure that you have these options down the bottom. So graph, calculator, test, etc. If you don't, either press exit or the arrow button, the F6 button to get across so that you have these options. So graph should be in the bottom left-hand corner. We're going to look at F2, which is the calculate function. So press F2, and then the F1 button, which corresponds to 1 VAR. So we're looking at that, all those values, which tell us, again, the mean, a little X with a line above it. But we want, at the moment, the range and interquartile range. So to do that, we're going to use the maximum minimum for the range. So remember, the range is simply maximum, subtract away the minimum value, which for this set of data is 12 minus 4, which gives me a range of 8. Okay, so the maximum, which is 12, minus the minimum, which is 4. Interquartile range. So let's do that. The IQR, which is Q3 minus Q1. So for this set of data, it's 9.5 minus 6.5. Now your graphics calculator doesn't actually do these simple calculations for you. You have to do it, but it does tell you the values you can use. So that gives me an interquartile range of 3. We spoke about range and interquartile range and also using this as a way of comparing sets of data. So alone 8 and 3 for a range and interquartile range doesn't mean much when I'm looking at sample A. But if I then compare that with the range and interquartile range for sample B, that helps me make a comparison. So for sample B, the range is still the maximum minus the minimum, and the interquartile range is still Q3 take Q1. But what are those values? So let's go ahead and look those up. Exit, because this is for list 1, those values for list 1. So now I'm going to look at the values for list 2. Now to get that, I need to change the set that I'm looking at. So at the moment I'm looking at list 1. So if I click on F6, which relates to the set, I'm going to change that list 1 to list 2. Okay. Exit. So then again, if I press F1 for my first variable, I will have the data here for that second list, or for sample B in this case. So if I scroll down again to my maximum, which is 10, and my minimum, which is 6, gives me a range of 4. My Q3 is 9 and my Q1 is 7, so 9 takes 7 is 2. Alright, and that gives me a range of 4 and an interquartile range of 2. So if I was comparing these two sets of data, I would say that, looking at question B here, which sample appears to have the greatest spread, I would say that sample A would have the greatest spreads. Just looking at those two values. The range in this quartile range is a little bit higher in sample A than it is in sample B. So sample A, greater range. Sample B, the range is smaller or more consistent, I would say. Now, range and interquartile range are good, but they're really only using two values each. So the range obviously uses the maximum and minimum value. The interquartile range uses the Q3 and Q1 values. So actually a more preferred way to measure spread is actually using the standard deviation, because it sort of it looks at the deviation from the mean of each value. So it's actually taking into consideration each data point, not just two values to determine a range. All right. So again, I won't talk too much about it. I won't go into the details of the formula, but I'm going to grab that data straight from, or the standard deviation straight from, here, my graphics calculator. I've already put in the data. It's giving me the standard deviation. So there's a population standard deviation, which is this symbol here. I'm looking at this. This is asking for the sample standard deviation. So that's the SX value there. So the sample standard deviation for sample B, I'm still on that set of data, is 1.08. So standard deviation is 1.08 for sample B. If I go back to my first list, again, I'm going to have to change that set from list 2 to list 1 again. And then my standard deviation is there. Again, the population standard deviation is 2. The sample standard deviation is the one we're looking at here, which is 2.04. So for sample A, standard deviation is equal to 2.04. Okay. And then again, we can compare these two values. Again, the higher the number, the greater the spread of data. The lower the number, the more consistent the data is. Okay, or the closer those values are to the mean. All right. So if I was answering this question, do your results agree with your answer to B, which said that sample A had a greater spread? Yeah, it does, because the standard deviation, or the sample standard deviation, is in fact higher in sample A as opposed to, or compared to, sample B. In fact, all these measures of spread in sample B are lower than what they are with the data from sample A. So that's it. That's how you work out standard deviation, and a little bit about standard deviation using the graphics calculator.